I'm Jonathan Tomkin from the University of Illinois. Fossil fuels dominate the energy portfolio of the United States. Note that oil and coal are down from their peaks, while natural gas continues to increase. Natural gas and coal are very important in the US electricity supply, and one of the reasons for this is they have a very high energy return on energy invested. Coal is about 100. They also have many of the other advantages of oil. They're energy dense, they're cheap ways to produce electricity, and in fact in some places getting cheaper, and also they're sources of supply that can be stored. We can turn on a natural gas turbine when we need the energy. We don't have to wait for the wind to blow or the sun to shine. So because these supplies of energy have not been running out in the United States, prices of electricity have been broadly flat over the last 50 years. Coal is still the cheapest technology for delivering electricity in the United States. Coal has another advantage all around the world. It's available in places where oil isn't, so there aren't security concerns. Again, this is because coal is the product of natural processes, and so there is a geologic reality of where coal is located. Some of the biggest industrial countries in the world, places like China and the United States, also have plentiful supplies of coal, so they can use that coal to supply their industries. Of course, coal has major issues. Perhaps the most foremost for a course like this is the fact that it produces more carbon dioxide per unit of energy than any other energy source that's used widely. It also produces other environmental effects: acid rain, mercury and heavy metal contamination, ash and sludge. It does appear that there is a lot of coal left. Although some countries, such as the United States, are using less coal now than they did in the past, our point of peak coal use was in 1998, total reserves are thought to be very large, and worldwide peak coal is not expected to occur for decades yet. Most experts think that at current rates of use, there's enough coal for the rest of this century and for some of the next. So, as from a sustainability point of view, the danger of coal is not that we'll run out of an energy source. The danger is that the pollution that it causes is not something that we can cope with. There is another fossil fuel which is not quite as dirty. In particular, it produces less carbon dioxide, significantly less, per unit of energy produced, and that is natural gas. Natural gas also has less security concerns than oil, as it's found in many more places, especially the new unconventional supplies, such as shale natural gas. New fracking technologies has meant that we can extract natural gas from many places where it was previously thought not possible to do so. This has increased reserves enormously. 10 years ago, when I first started talking about sustainable energy supplies, the global estimate was around 50 years of use left. Today, because of advances in technology, experts have said that there could be 200 years worth of use. So natural gas, like coal, can see us well through the 21st century. Again, however, it produces carbon dioxide. So the question is not, will we run out of natural gas? The question is, can we handle the pollution produced? Furthermore, just as we saw for extracting unconventional oil supplies, there are additional environmental concerns from extracting unconventional shale natural gas supplies. The fracking technique is not very well tested and could cause additional environmental problems. For example, fracking requires the pumping of high-pressure fluids into the earth, and it's not clear what is exactly in these fluids. They have chemicals in them to make them slippery. Some people worry that if these chemicals get into fresh water supplies, then we could contaminate aquifers. Geologists think that as long as the aquifers are far enough away from the natural gas shales, and often they're separated by hundreds or even thousands of feet, then there shouldn't be very much contamination between the two. And the general consensus at the moment is that although unsafe events can occur, it's not any more inherently unsafe than any other methods of extraction. Nevertheless, it's a new technology, and it's possible that there will be unforeseen or even foreseen problems that will outweigh some of the benefits. But as a consequence of this new technology, supplies are going up, extraction is going up, and there is no peak. There's easily enough natural gas to supply consumers in the United States and Europe, two big industrial centres, throughout the century, and that's from local supplies. So coal and natural gas could see us through the century. But remember, this coal and natural gas took millions of years, tens of millions of years, to create. So we are using them up in an unsustainable fashion. And if we look at the scale of civilization, which lasts for centuries and even millennia, we can see that our current methods are not things that we'll be able to do in the long term. And of course, there is a bigger environmental problem. The trend in carbon dioxide emissions is not sustainable. If we continue to use oil, natural gas and coal at the rates we've been using them, then we're going to make a much larger change to the climate than we would be if we started to reduce the amount that we used. In fact, it's possible that we might need to do things like geoengineering to try to counter the effects of the predicted large increase in temperature that would be caused if we used up all of our fossil fuel supplies. So moving away from fossil fuels is a big challenge. Remember that these three types of fossil fuels are around 80% of the world's energy portfolio. So this is one of the hardest challenges that the world faces in becoming more sustainable. What are our options? We'll start looking at those options in the next lecture.
Produced by OCE Atlas Digital Media at the University of Illinois, Urbana-Champaign.